Before we dive into India's rich tapestry of history, let's rewind a bit. Actually, let's rewind a lot. We're going all the way back to where it all began. The Big Bang. 13.8 billion years ago, the universe sprang from a singularity, rapidly expanding and cooling, giving birth to fundamental particles and energy. This rapid expansion, known as cosmic inflation, happened in a blink, stretching the universe from subatomic scales to cosmic proportions. As things cooled down, protons and electrons paired up, creating the first hydrogen and helium atoms. This process, called recombination, occurred about 380,000 years after the Big Bang. The universe then became transparent, allowing photons to roam freely, forming the cosmic microwave background radiation. These early atoms were the building blocks for the first stars and galaxies. Fast forward to 13.5 billion years ago, gravity began pulling together clouds of hydrogen and helium, sparking the birth of the first stars. These stars ignited nuclear fusion, turning hydrogen into helium and heavier elements while lighting up the universe. Over time, these stars lived their lives, exploded as supernovae, and spread their enriched guts across space, seeding the next generation of stars and planets. 500 million years later, stars began to cluster into galaxies, including our very own Milky Way. These galaxies were held together by dark matter, which exerted the gravitational glue that kept everything in cosmic order. Over billions of years, galaxies merged and mingled, shaping their size, structure, and star distribution. About 12 billion years ago, the Milky Way itself began to take shape through the merging of smaller galaxies. Drawn together by gravity, these smaller galaxies contributed their stars, gas, and dark matter, gradually building up the Milky Way's iconic spiral structure. This cosmic cannibalism isn't over. Even today, the Milky Way continues to snack on dwarf galaxies like the Sagittarius dwarf spheroidal galaxy. Now, fast forward to 4.6 billion years ago, when a molecular cloud within the Milky Way decided to collapse, leading to the birth of the Sun and its entourage of planets, including our Earth. As the cloud collapsed under its own gravity, it spun into a disk, with the Sun at the center. Dust and gas within the disk clumped together, forming planets, moons, asteroids, and all the other bits and pieces of our solar system. About 100 million years later, Earth formed from the leftover dust and gas after the Sun's birth. In its early days, Earth endured countless collisions with planetesimals and protoplanets, growing in size and heating up until it became a molten world. Over time, the heavy stuff like iron sank to form the core, while the lighter materials floated up to create the mantle and crust, paving the way for the atmosphere and oceans that would eventually support life. A Mars-sized celestial wrecking ball crashes into baby Earth about 4.5 billion years ago, sending debris flying everywhere. That cosmic shrapnel didn't just drift off into space, it stuck around, eventually forming the Moon. This colossal impact, known as the giant impact hypothesis, was a game-changer, tilting Earth's axis and setting it spinning just right to give us seasons. The Moon's birth wasn't just dramatic, it also helped stabilize Earth's tilt, becoming the planet's loyal tidemaster. Earth didn't get much of a break after that. Around 4.1 to 3.8 billion years ago, it entered the late heavy bombardment phase, where it was pummeled by asteroids and comets like a cosmic punching bag. These impacts not only sculpted Earth's early surface, creating basins and craters, but they also may have delivered crucial ingredients like water and organic compounds. This bombardment didn't just leave scars, it played a key role in shaping Earth's early atmosphere and setting the geological stage. After all that chaos, Earth finally started to cool down a bit around 4 billion years ago, and its outer layer hardened into the first stable crust. This wasn't just a cosmetic change, it marked the dawn of plate tectonics. The rigid crust broke into pieces, or plates, that began drifting over the semi-fluid mantle below. This early, primordial crust eventually recycled itself through the process of subduction, paving the way for new crust to form and for the first continental landmasses to take shape. As Earth continued to cool, the first protocontinents began to emerge, kicking off the slow dance of continental drift. Driven by mantle convection currents, these early landmasses started moving, bumping into each other, and shaping the early supercontinents. This initial drifting laid the groundwork for the assembly and eventual breakup of supercontinents like Rodinia, which would go on to influence Earth's geological and climatic history. Meanwhile, in Earth's early oceans, around 3.5 billion years ago, life was getting started. The first microbial life forms, including cyanobacteria, began to appear, with stromatolites as their calling cards. These microbes weren't just hanging out, they were busy photosynthesizing, pumping oxygen into the atmosphere, and radically transforming the planet's environment. This was the beginning of a chain reaction that would eventually lead to more complex life forms. Thanks to those industrious cyanobacteria, the Great Oxygenation Event was underway, filling the atmosphere with oxygen about 2 billion years ago. This was a major turning point in Earth's history, as the increase in oxygen led to the formation of the ozone layer, protecting the planet from harmful ultraviolet rays. This newfound shield allowed aerobic organisms to evolve and paved the way for the development of more complex, multicellular life forms. Finally, as Earth's continents continued their slow-motion shuffle, they collided to form the first known supercontinent, Rodinia, around 1.3 to 0.9 billion years ago. This massive landmass brought together much of Earth's surface, influencing global climate and ocean circulation. Rodinia's assembly was a key moment in Earth's geological history, setting the stage for future supercontinent cycles that would continue to shape the planet. So, in just a few billion years, the universe evolved from the explosive birth of the Big Bang to the formation of Earth and the emergence of life. From cosmic collisions to the birth of stars and continents, these events set the stage for everything we know today. In the next video, we'll explore how India itself was formed, shaped by the forces of geology and time. Stay tuned for the next chapter in India's incredible story.